All right, we'll go ahead and get started with this lecture and coding demonstration of ASP.NET with Entity Framework. And so what we're doing basically with this Entity Framework is the dependency in .NET that will allow you to write what's called code first, where you write C# classes and integrate it with your database. And so when you hear Entity Framework, you just got to realize that you're talking about tying in your web application to your databases. So this screen that we're looking at, this data is now coming out of a database. And so this is new for us in this class because we haven't really tied in databases yet. And unlike our React class, where it took us a lot of time, we learned Mongo and we learned Express and we learned to build a full stack app. I mean, it took us like 50 days because we did what was called horizontal slicing. The way we learned the stack was horizontally. Now we're kind of doing more vertical slicing. I mean, we're just doing the front end and the back end kind of all up front, like really here at the beginning of the class. And so, yes, we've got a full stack CRUD application where we can do updates, right? We can create new car, right? So we can create new cars, we can edit those cars. If I don't have data validation, we got data validation. Okay, now a couple other things to notice about this CRUD app, and I'm just going to point it out. Take a look at the URL. As this URL changes, like if I edit, this is kind of a cool little feature, these readable URLs where you're putting some of the product information in the URL that just kind of confirms that you're on the right page. It's also the case that, like, look at this form, make, model, and year. Right, we got 3 text boxes with make, model, and year. But notice when I do an edit, I've got make, model, and year. So we've got these views, and this view is an add and edit view. And so we're kind of reusing some code here. Essentially, because the form is the same, we're able to reuse the view for multiple operations. Again, for an adding a car and an edit of a car, we're reusing the form. Okay, so we've got Tailwind, we've got MVC, we've got Entity Framework, we've got data validation, we've got CRUD, okay? And that's essentially what we're building today. And this is chapter 4 of our book, how to develop a data-driven MVC web app. And I will tell you that this is a really good chapter. It is definitely worth going through, but I will also tell you that this book is a couple of years old, just a couple of years, and there's already been significant updates to the code that's written, specifically around asynchronous code. So I've gone through here and I've just made all the code async awaits because that's a best practice. So this code, I've updated it in a couple of different ways, one of which is async awaits. So again, if you want to get into the actual objectives, when we get into databases, we're going to talk about SQL Server databases along with these database tables. And so remember, in Mongo, we had collections. In SQL Server, we have tables. Same idea. You got rows and columns of information. But Mongo was a non-relational database, and these are all relational databases. And when you have relational databases, everything in a relational database kind of starts with its understanding of a primary key. And what is a primary key, and how do we code by convention for a primary key? Because this Entity Framework creates code first classes that'll generate our database tables with primary keys. Okay, so a lot to unpack there. We're going to learn about this database context class that will map our entities to the tables. We're going to actually create what's called seed data for our application. So we're going to load up our tables with data. We're going to define a connection string, so to connect from our application to the database. We're going to get into this concept really early in .NET. When you're in .NET, you're going to hear a lot this term called dependency injection. Okay, and we're going to use dependency injection to pass an object into a controller. And so a lot to unpack about dependency injection here. We're going to be writing some link. You guys remember from your C# days and how to query a database, right? You can query a database with SQL or you can query it with link. They're very similar languages. The idea behind link was it's supposed to be language kind of agnostic. You know, you could write link in Java and you can write link in C#. So it's supposed to be kind of cross-language technology to query a database. And so with C# and with Entity Framework, you write a lot of link queries as opposed to SQL queries. All right, we're going to do CRUD. Again, we're going to work with primary keys and foreign keys. And we're going to get those user-friendly URLs that I demonstrated, including what this is called a slug. So there's a couple ways to make our URLs more friendly than what comes out of the box. Okay, so this is what we're creating. Those are a list of objectives. There's my demo code. As you guys know, I like to lecture by giving a code demo. So I will unpack these concepts as I code, and like I like to do is I'm going to start my .NET project with an empty template. And this is an ASP.NET Core empty. And so C# and web are my filters on my drop downs. And I'm just going to call this my car lecture demo. And what I don't love about this is it does, even though I can go through this really fast, it does require a little legwork to get off the ground up and running when you start a project from empty. Okay, so bear with me as I kind of spin up the basics here. Last chapter we did not have a models folder, but we are going to work with. We did have a models folder. I forgot. You know what? We had a models folder, but it didn't tie into an actual database. Thank you. Now we've got MVC, models, views, and controllers. Remember, under views, there's also a subfolder called shared, which is where we put our layout file. Add an empty class or add a new item, and I just search for layout and add eraser underscore layout CSHTML. And kind of back here in the program CS, we need to enable builder services, add views, add controllers with views, app.use static files. Remember, okay, so this enables MVC, just kind of rehashing this, right? This enables controllers with views as part of MVC. So this kind of enables MVC. Use static files does what? It says, well, hey, go ahead and anything that's in a www root folder, all your static files should go in www root, and those static files should be accessible to your views, including your layout. Now, for sure, what we're going to do, as we've done several times now, is we're going to add a CSS folder to put all of our CSS in. and the like. Okay, so that's app.use static files, and we also did something with routing. We said use default route, use default. Oh, that wasn't exactly what it was. Route to default, something along those lines. Default, is it default? Is that all it was? Default routing? No, okay, let me look at it really quick. What is it, guys? Someone look at their code for me. Because I already updated my code, because I don't use this anymore. Map default controller route. Does that look right?
Yeah.
Thank you. Okay, so we're just spinning this up. Okay. Inside of views, then, there's a view start. So let's add a file called, I just searched for start, razor view start. And this kind of sets the underscore layout for all of our views to be that. So when you have a view start, everything that's in this views folder will use underscore layout for. So underscore layout, this is our HTML5 template, right? So view start says use underscore layout for all the views inside of this views folder. And there is another file here called view imports. So again, this is still in the root. We're going to add a new item, view import. And these underscore view imports, there was a couple things that we put in here. The first is our models folder. So at using car lecture demo dot models, and because I haven't actually made a I don't know that I've made that namespace, in the sense we got a bunch of empty folders but not many files. You need an actual file in here for this namespace, I believe, to be recognized. So the one model I'm going to create is a right-click, add a class called a car model. Now this kind of declares the car lecture demo namespace dot models, and this should resolve. Cool. So that's why that wasn't resolving. There was also this line here called tag helpers. Now, something really interesting about this. You know, these tag helpers, we used this tag helper to help us formulate some links. Like we had anchor tags and we said ASP action. Remember that? I think we said anchor tag ASP action. And there is no ASP action attribute on an anchor tag in HTML5. So Microsoft makes these tag helpers, and you can use these tag helpers. That's something that's built in. I had an alumni reach out to me this weekend who works in .NET MVC, and he was telling me about at his company they make their own tag helpers. And I thought, that's interesting. I didn't even know that you can do that. He goes, you should share that with your class. I said, okay, I'll share that with my class. We're about to talk about tag helpers. Whatever, just little tidbit. Microsoft provides a bunch for you, and you can apparently make your own tag helpers. So there you go. Okay. Now, I'm also going to make a car controller. I'm going to make a car controller. Again, this is not the home controller, but the car controller. Again, convention here makes a difference, like the entity followed by the suffix, the word controller, capital C, capital C. So convention here matters in .NET. So the car controller will work with the car model, and I'm going to rename this cars controller. Add controller. I could probably get by with singular, but I'm going to make it plural. I think that's the convention is plural on your controller name. Therefore, under views, because cars is plural, I'm going to make a cars folder and an index view. Add new item index. Index. Oh, I didn't mean to make that a class. Excuse me. Right click, add a view, razor view, index, CSHTML. There we go. I don't know, I did that too fast and got rid of the CSHTML. Okay, so you can tell that my home page is no longer going to be the home controller. I'm going to modify my landing page. Instead of using the home controller in the home folder, I'm going to use the cars controller with the cars there. And so this whole idea of routing, now we're going to begin to customize our .NET routing. And so this is going to look a little bit different than just saying map default. I'm going to say map controller route. I did that earlier. Okay, and so I'm going to say, hey, this is my default routing pattern. And the pattern is going to look something like this, except for what we have here is we're going to start with the controller. So this is your URL. And in the URL, you start with the name of the controller. Then you go to the action, which again, action is another word for method. So this is the name of the controller. This is the name of the method in the controller. And then ID is, if you have a method, an input to that method are your parameters. And so this is an optional parameter that would go into the method. So again, the name of the controller, the name of the method, and then this ID is an optional input parameter into the method. Okay, but our controller here is not home, it's cars. And I need to put a semicolon. Okay, so now I should hit my cars controller index. So car controller right there, index. It just returns the view that's right here. And then I'm just going to say, welcome to my cars collection. Okay, now I don't have Tailwind brought in yet. You guys know how to do that, but let's boot that up. Nothing really new yet, except for that routing thing. Okay. Okay. See if I can do this from memory. I'm going to bring in Tailwind. npm init y. Even though the node modules folder isn't really installed when I bring in that dependency, let's go to the Tailwind CSS documentation and docs and Tailwind CLI. There's the command that we run next. npm install Tailwind and the Tailwind CLI. I then go into my CSProj file and I bring in this chunk of code right here, okay, that basically will take the input file of site.css, which we have not created, and compile it down into an output file that's a minified CSS file that only uses the classes and the aspects of the Tailwind library that you need. And so I do need to create this in site.css, add a item, a CSS, and this is site CSS. I believe it's import Tailwind. I don't think that, I think it's import Tailwind CSS. Let me, inside of quotes, thank you. Okay. So this imports Tailwind CSS. And last but not least, we go to our layout file and we need to link to that output file. This is a very standard link tag in HTML. The relevance is that it's a style sheet, so rel attribute. href says go to the static files, the root of your static files, which is www-root. So this kind of says go to the root of www-root. CSS folder, output CSS. And now if I just go ahead and do a build, this build should produce my output CSS file, because that's what our command told it to do in that CSProj. So there's output CSS, there's output CSS. Now let's just rip, what do we want to rip? A nav bar. I just want to, because what I've done a couple of times, so if I just go components, documentation for the components, okay, let's go application UI, headings. Okay, so Tailwind docs, you'll find out real quick. If you can get access to the code, there's a code tab, and that's nice. But real quick, it says get the code. Anything that says get the code, you have to pay for. That's not really a nav bar, is it? That's just a heading. So, okay, there's under stack, here's application shells, stacked layout, sidebar layouts, multi-column layouts. Let's go stack layout. This looks nice for our, for the application shell, a stack layout. That looks nice. Let's grab that. This is 4.1. There's our script tag. I like that. That looks like a better starting point. Now, again, whoops. If I go back to the preview, okay, so dashboard, and let's see how I can bring this in. So I just take all this. Now there's your content, render body. And we go to the top and include this, bring that in. We've seen this a couple times. This example requires updating your template. Okay, so we can throw this on the HTML. Oops. Body class h full. Okay, so we've done that. Let's save it. I like this a lot better. Much nicer. Okay, let's see if that looks decent. All right. Welcome to my cars collection. Even though, now I got to break this down, right? I mean, anytime you just rip all this into your code, there's the word dashboard. So maybe welcome to my cars collection. And I'm just going to turn one of these navbar links into add new car, right? So I don't need 1, 2, 3, 4 links. I just need my one link. So if I'm looking at this, here are my links. This is no longer my dashboard. This is my cars collection. And this becomes add new car. And then these can be deleted. Okay. And we can that's nice for later on when we get into our accounts and registering accounts and all that fun stuff. So we're looking good here with Tailwind. Now into the new stuff. Okay, describe how you can code a primary key for an entity by convention, and describe when the value for the primary key will be automatically generated. All right. I'm going to do that right now. This is an important thing to realize. So zone in. I know this Tailwind's been kind of easy to zone out. What we're doing here, we're going to be working with entity framework. And it literally spells it out here. Entity framework will recognize a property named ID or car ID. So either ID or car ID will be the primary key by convention. So how do I make an auto-implemented property? We're going to say prop int car ID. This right here, line 11, will be the primary key value. Remember primary key. A primary key is in a database table, right? A database table has rows and columns. A primary key's job is to enforce uniqueness. So you should not have 2 rows that are duplicates because of the primary key. So a primary key value, its job is to make sure that no 2 rows have the same values. Now, in Mongo, remember Mongo had auto-generated primary keys. Essentially, they had GUIDs. Remember our unique identifiers on Mongo? Okay. This car ID, by default, it'll just be an auto-incrementing number. It'll go 1, 2, 3, 4, 5, 6. It'll auto-increment every new row that you put in. It'll just auto-generate a new number. You can change that to be a GUID, and we will. But now, just for the sake of this getting started, now if you do something funny like this, that's not going to work. If you do something funny, will ID work? I don't know. I wouldn't test it. It's supposed to be ID, capital I, lowercase d, or car ID. Okay, the name of the class followed by the word ID. Okay, so that's how you make a primary key by convention. By the way, I said, hey, we're working with Entity Framework here, and I skipped this step. Well, what's this step? Well, just like in Node land, remember in Node we had all these dependencies, right, that ran on the server. There are dependencies for Entity Framework. But instead of running the npm package manager, we run the NuGet package manager. So that it's just a different name, but it's the same thing. It's a package manager. You're bringing in dependencies that other people have wrote. Microsoft wrote these dependencies. And we're going to bring in 2 Entity Framework dependencies. So I'm going to do that now. Okay, now these dependencies, if you click Browse, I'm going to search Microsoft. There's the snippet, if you're going to take notes, like these are the 2 dependencies that you want to bring in. It's Microsoft Entity Framework Core.tools. So you click on Microsoft Entity Framework Core.tools. You click on the project. You're working with .NET 10, so we want .NET 10. You want the matching version numbers here. .NET 10, .NET 10. So we're going to click on Install. Okay. And we get the little finished note there. Let's clear this out. Microsoft Entity Framework Core SQL Server. When you type this out one time, that'll show up on your history like it does mine, but you got to type it out the first time. So here, this one is for SQL Server. Okay, SQL Server is the Database Management System, DBMS, DB, Database Management System. It's kind of your software for managing databases. If you guys are making a Word document, you use Microsoft Word to create Word documents. You use SQL Server to create databases. Okay, so SQL Server is our database management system. We need SQL Server for Entity Framework, and we need tools for Entity Framework. Those are the 2 dependencies that we bring in. Okay, and we get the little finish tool here. Clear this out. If I just click on the installed tab now, you get these 2 green check marks for the dependencies you've brought in. Okay, so now we're ready to start working with Entity Framework, and you can see now I am referencing these packages. Okay, when it comes to a car, what other attributes do you... So the way this is going to work is that this is called an auto-implemented property. It's an auto-implemented property in C#. You learned about this in your C# class. Okay? So for every auto-implemented property, that becomes a database table column. It becomes a column. So car ID column, right? There will be a make and a model and a year. I'm just going to keep my model pretty simple. I'm just going to say make, model, and year. So I'm just going to add a few more properties, auto-implemented properties. And I'm going to mark them as required. Remember, this data annotations namespace is needed to mark these as required. That's data validation, right? You cannot add a new car without giving it a make, a model, and a year. Okay, so simply marking these as required, you guys have seen that now. You remember that from last chapter.
Shouldn't car ID be required as well, or is it special?
No, it should be, and it automatically will. It's a implied thing. Yeah, and I'll show you that when we create the database table. You should not be able to do that. I guess we could be explicit and just mark it as required. Although again, I think it's automatic. For sure, it is required though. Okay. So again, this is Entity Framework. This is the dependency that we've brought in. And Entity Framework comes in different flavors. There's Entity Framework Code First. So this is one flavor of Entity Framework called Code First Entity Framework. What does that mean? Code first. That means we're writing C# code. We're writing our C# code, and that will help us generate our database. Okay, now there's a database first entity framework, which means if like you already had a database and you want to create C# classes from that database and those database tables, you could do this. But this is one flavor of entity framework called code first. Okay, so like the steps that I'm going to take next, like we have our car class, our simple car class. It has a primary key and some additional fields or some additional properties. What I need to do is actually create the database and create the table, because this will be a car table. Did I say that already? I don't think I did. This car class will become a car table. And then these properties will become columns. Okay, but there's a little bit of code that's required to make that happen, and that's called around a database context class. So inside of the models folder, I'm going to add a new class called car context. And the car context is, I think of it as like the connector between the C# car class and the database. Okay, so this kind of connects our car class to the database. It has a CS, carcontext.cs. And this is going to be kind of a new syntax for us. There is a modern way of working with constructors. Now up top, let me bring in a using statement. Okay. Another thing that I did with this is I updated the old C# in the book with the new modern C# features, of which we've got one called a primary constructor. I think it's called. Is it called a primary constructor? I think it's called a primary constructor. Primary constructor looks like this. It says that our car context first off has a parent of DB context. So this is just inheritance. But then what we do is we say, hey, we've got one DB context options. This is, again, car context called options. And this passes those options up to the parent. Okay. So this is a weird syntax for this. But what this is doing is now we don't have to make our constructor. The constructor is all right here. The constructor for this class, the class is called car context, has one input variable called options. And you just pass these options up to the parent. The parent class you're inheriting from is DB context. Okay, so this is just kind of an abbreviated syntax for this car context using this primary constructor syntax, new C# syntax. So that's why we did the new C# review, because you guys should have seen this by now. Okay, now this is different. This will create a table called cars, right, of data type car. Car is our class, right? So we're creating a DB set, which is a table. We're creating a table of type car. The table's name is called cars. Okay, so this is a file. This file is going to link our database from the car class to the cars table. All right, so that's kind of step one. Step two is I'm going to write a method here inside of my car context, protected method. So the access modifier is protected. Override void on model creating, model builder. Okay, so this is just the method that we're creating. So when we're creating the table, here's what we're going to do. When we're creating the table we're going to put some data into the table. So model builder entity, we're going to put entity type of car has data. Okay, and this is our seed data. So we got a Toyota Camry, Honda Civic, and a Ford Mustang. So if this works, okay, and we got a few more steps, we're going to create a table, and that table is going to have 3 rows of information in it. Okay, so now we are ready to actually make a connection string. We need a connection string. Where do you store the connection string is going to be in this app settings.json. Okay, we're after this allowed hosts. There's a connection strings here. The name of my connection string, I'm going to call it local database connection string. So we're defining our connection strings. Again, connection string just connects your application to your database, kind of very similar to the car context. But this is like the actual, what are the credentials needed? You guys will need on your Visual Studio, if you haven't done this, click on View, and then click on SQL Server Object Explorer. So you should have SQL Server Object Explorer on the left-hand side for you. So View, SQL Server Object Explorer. This is a tab that we're going to work with in this class. This allows you to see your instance of SQL Server. Mine's called, it's called local DB / MS SQL local DB. Like if I rename this, this is the name. I think of local DB as a version, and then an instance is MS SQL local DB. So when I say server inside of this connection string, the first thing I'm going to say is server local DB / Microsoft SQL local DB. You know exactly where that comes from. That's the name. Local DB is the version of SQL Server. There's many versions. This is the free version. Think of this as the free version. And then the instance MS SQL local DB. The name of my database will be cars. I'm just going to call it DB2. I already have a cars DB. I did that for a demo. I'm going to call it cars DB2. That's the name of my database. I have to say trusted connections true. And then I don't know that this part is necessary, but the book has it and I've always included it. Multiple active result sets to true. Okay.
It won't be using like a database kind of thing like MongoDB?
Our database is going to be on our local computer for now. Okay. We will get our databases on Azure.
Okay.
But for now, we're going to have them on our local machine. Okay. Okay. So now we've got our kind of connection string defined inside of our app settings JSON. Back into program CS. So this line here is going to allow us to send in a car context. Okay. This is car context. Remember in C# you learn how to make a class, you make a blueprint, you call it student, you say student S1 equals new student. Student S2 equals new student. To create an instance of the class, you use the keyword new. Remember this? Create an instance of the class keyword new. Dependency injection allows the runtime to actually instantiate your objects and then pass those objects into your controllers. Okay, so what we're going to allow this application to essentially create its own instance. You don't have to hard code it. It'll create an object for you and then pass it in to the controller. Why that's useful is this car context. The car context is going to be used to interact with the database to actually update the database, add new items, to do all of our CRUD operations. So dependency injection is going to allow the runtime to actually instantiate objects for us and pass those objects in to our controllers. This line of code allows us to do this. Actually, builder services add DB context. This is called car context. Of course, it's going to need a using statement up top, which it did. Options arrow. Options use SQL Server. Use SQL Server with our connection string. Builder, configuration, get connection string. Except for what did we call our connection string? We called right here, our connection string is called local DB connection string. Whoops. Don't cut, copy. Okay, now if I fix my, I think I need one more. Okay. So this is going to allow our controller to get a car context. Our car's controller. Right now our car's controller is not receiving anything, but it will here in a minute. Okay, save. When you get to this point, we've got seed data, we have wired up a connection string, we've linked that connection string to our local database. Now we're ready to run two commands that are built into Entity Framework. I'm going to go to my package manager console. I'm going to run one add migration initDB creation. Okay, so this command is called add migration, and this is going to be the initial database creation. That's why I called the migration initDB creation. If I did it correct, it'll build and not have any errors, but there's also a chance I missed a step. I am doing this from memory.
So this is building off the models you've already made.
Off of the models I created and the seed data that I created. Okay, build succeeded. It'll create a file. It'll create a new file that you just kind of look at. And we can just kind of look at this file. It's got a method called up. Notice when I run this up method, I am creating the cars table. The cars table has these columns in it. Notice these data types. These are SQL Server data types. And varchar max, integers. Okay, it's got a primary key column called car ID. Now I do notice that I hard seeded the 1, 2, and 3. Notice the car ID is getting the value 1, 2, 3. The make is getting Toyota, Honda, and Ford. The model, Camry, Civic, and Mustang. And the year. Okay. Why? Well, it's because I auto-filled that, right? Car ID is set to 1. I don't know. I've always manually done that. I've always included the primary key values, even though it should auto-generate them for you. I just say, okay, 1, 2, 3. Okay. So this migration creates a file that will create a database and create tables and insert data. Like literally, this is a SQL insert data command. Okay. And this is done inside of a migrations folder right here. You could see this is where this file is created. If I close this file down, open it back up, this is called a migration file. Okay, now to actually run this file, because this file, you just run this update database command. So you do an add migration, give the migration a name. If it works, you update the database. And okay, if you get this error message, then you're happy because it didn't error out, which means I should be able to refresh my SQL Server, go into my databases. These are my databases. Here's my CRUD DB2 database. And here's my cars table, and I can view the data. And okay, we've seeded data, we created a database, we created tables, we put data into the table, and now we're ready to create an actual web application now that we've got that foundation laid. Okay, so number 2, describe how a DB context class maps related entity classes to a database and seeds the database with the data. Well, again, we go back to the context class. The first thing you got to realize is that you have to inherit from this entity framework class. Okay, and you have to take this constructor, just take in these options and pass it up to the options. Literally, this is just boilerplate needed. Okay, now this entity framework class creates a table name based on the car entity, right? By the way, this is called a model. Specifically, this is a domain model. Okay. Models, right? Classes. This is referred to a domain model, meaning it's going to link up to a database, meaning represents a concept within the problem domain and links to a database table. Okay, there are other kinds of models, by the way. Another model that we will talk about before very long is called a view model. Okay, just throwing that out there is something to look forward to. Okay, but this is called a domain model. Okay, back from a brief little break here. Number 3, name the file that's typically used to store a connection string to the database. And the answer to that is appsettings.json. Appsetting.json stores your connection string to the database. And then the next bullet, how does a program CS read a connection string from that file? So program CS calls a get connection string method to read from your app settings JSON. So it's builder.configuration.getConnectionString, and then it basically local DBCS, it has to match local DBCS. Okay, also right here, this is the name of your database file. You get to name your database. You get to name your database right there. See what else we've covered. Describe how .NET Core uses dependency injection to pass the DB context objects to controllers that need them. Well, step 1 is you have to inject this car context. It's done with this builder services add DB context. Okay, this line right here injects the car context into the controllers. Well, what does that look like on the receiving end? Right? Remember, we no longer have to create the instance of that class. That will be done for us at runtime. We are going to make a read-only car context called underscore context. And we're going to initialize it on the constructor. This is the constructor for the cars controller class. Notice we initialized underscore context equal to context. So this object, notice we never had to say the keyword new. Whenever the cars controller is instantiated, a cars context object will be sent in, and then we will assign this instance field, this field right here, underscore context, equal to that of the car context. So now this underscore context, this variable, allows us to interact with the database. So what are we going to do? We're going to get the cars out of the database and put them onto a web page, right? So underscore context is our variable that's going to allow us to interact with the database. Remember I said I made everything async, so I'm going to make this index an async method. Therefore, it must return the data type of task iActionResult. This will allow us to await our database, and instead of returning to a view with nothing in it, we're going to await underscore context. So this underscore context dot, we got some IntelliSense here, cars table, which really this cars context only has the cars property, to list async. So basically go into the cars table and turn the cars table into a C# list async method, because there's two lists and there's two list async. One's asynchronous, one's not. So line 18 will send a list of cars to the view. Where's our view? Right here. Now, your model, in this case, is not a single car, but a list of car. You could do list of type car, and that would make sense. That's what this is, a strongly typed model. This model will work with a list of cars. Instead of calling it list, you could say, hey, anything that's IEnumerable, a list implements the IEnumerable interface. So this is actually a more generic way of writing a list of car. This is another way of writing a list of car though. Okay, but it's a more generic way. And that way you could pass in a list, but you could also pass in, I don't know, anything that you can enumerate over, like a dictionary or something along those lines. Other collections that implement IEnumerable. Okay, but for right now, just think of this as a list of car. Now this is where it gets, you got to start bringing in some bootstrap stuff, right? So, of course, we're going to display a list in a table. And a table has a head and a body. So let's kind of get this formatted. We got a table. We got a T head, and a T body, table head and table body. Now the T body, we're going to have some boots, we're going to have some classes. Think about the table heading. You got make, model. So it's one table row, and I'll just save it, but basically one table row, and there's the make table heading, there's the model table heading, there's the year table heading, and then there's an actions, right? You're going to be able to edit, You're going to be able to delete. That's that actions column, the table heading column. Oops, I put that in the wrong. All of this is in the T head, not in the T body. Did anyone else see that? Or, anyways. So, okay, so these are our headings. One table row full of headings. And if I just kind of boot that up, it's not going to look like much yet. But we should still have a landing page to land on. Welcome to my cards collection. Make, model, year, and actions. This is a little razor syntax. At for each, we're looping over for each item in our model. Remember our model. Our model is our list of cars. And IntelliSense looks like it's taking a guess at this.
Car ID.
That's right. Item.car ID. And this is not, no, we're not doing this anyways. Okay. So the href for now, I'll just send to pound. We're not going to wire it up this way. Okay, but if you notice, for each, we have a new table row. So for each item in our model, we start a new table row. We put its make, model, and year. So at item.make.model.year. And then we also have our 3 links at the end here to edit, to view the details, or to delete. And we've got some different indigo colors, green colors, red, and little hover effects. Nice, got an extra parenthesis somewhere. But we are now little hover effects on our links. Number 5, describe how .NET uses dependency injection to pass a DB context option object to the controllers that need them. Number 1, you have to have that builder services add DB context line of code. Number 2, you have to receive it in the controller in the constructor. You receive it in the constructor, and then you assign it to an instance field back in the controller, right? You make this read-only field, and then you assign it equal to underscore context so that you can use underscore context to hit the database. Pretty cool. This is coming together pretty fast. All things considered, I mean, it took us 50 days to learn all the slices when we did horizontal slicing in the MERN stack, right? But here we are on the day 10 of this class, and we're able to pretty easily pull the data out of the database, and we're going to do full CRUD, which full CRUD, the edit is always probably one of the harder ones. Details and delete is going to be a little bit easier. So I guess we'll just do details next, since details is next in line there. Let me go to my view, my index view, find that rogue parenthesis. Where's that rogue parenthesis? Probably under my underscore layout. Oh, it's okay. That's in the view. So back to the view, and welcome to my cars collection. Where are you even at? Oh, maybe right there. Yeah. Okay, I think I found my rogue parenthesis. I did. Cool, so now what? We're working on details. And where I'll go for that next is my controller. Now I need to create a new method and a new view. I need to create a method called details, and I need to create a view called details. Of course, when I look at the details of something, it should expand the data. Okay, now I'm gonna get to the point where each car has more data about it. Right now, this is all the data about my car, but I'm gonna expand that. So for now, I'm gonna click on details. It's gonna show you the same data, but later on, it should expand it. Okay, so again, we need a new method and we need a new view. So that's where we're gonna start. Public async task action result is correct, called details. Now this takes in an ID. Remember back in program CS, we were defining our route for the first time. We said, hey, we start with the name of the controller, followed by the method inside of the controller, followed by an optional variable. This is a variable called ID. So that variable called ID, if your link is going to create that properly, that variable will send that ID into this method. So because this ID has to match this ID, these are variable names, they have to match. If they don't match, it doesn't work. No surprise there. Okay, so you can kind of start off with a little if the ID is null or something. If ID is null, we can return this not found syntax, and that's fine. Otherwise, we got to look the car up out of the database. This is link. We're going to say var car underscore context cars table. First, our default async, where this is just link syntax. C, the car ID, double equals the ID that's passed into the method. So again, anytime you see underscore context, we're going to hit the database. The table is called cars. The method says, get me the first car that matches this query, where the car ID equals the ID that was passed into this method. Ultimately, that comes from the URL. You know, if they pass in the ID of 10, there is no ID of 10, that car might be null, and we can return not found. Otherwise, we return to the view the car object that we just looked up. Okay, now what view do we send it to? We have to create that view. So under our cars folder, add a view. This is going to be called details. This details has a model of a car, a singular car, not a list of car. car details, and this is what
I thought you already created a view.
I created a view for a list of cars,
Okay.
right? This is a view for a single car to look at.
Okay.
Okay, so the car details will look like this, and we can change the title here. Right, we could change the car details title. Okay. So put all of this into a div. Okay, another div that just says car. Just a bunch of tailwind structure here. Okay. All this, I mean, this is just a whole bunch of markup in classes. That's not the thing to pay attention to. I want to show you this line. Okay. Everyone zone in for me line 12. Remember when I was looping, when I did this over here on my index, I just said item.year. I didn't prefix the whole thing with this HTML display name for model.make. You could just do this. Model.make at model.make. Oops. It's not at model, it's just model.make. No, that's not right either. Oh, shoot. One second here. Let me look at the syntax for this. Capital M. That's why. Okay. So this to me is obviously much easier than this. They both will return the same information. But this HTML display for is actually a little bit of an upgrade than just putting at model.make. Now if I just boot this up, let's just see that this in fact displays anything. Okay, Toyota Camry, if I click on details, okay, I haven't wired up my details, but if I do, I say cars details 1. Okay, notice I can change the URL and it does pull my Toyota car. So really this just needs to say make. So car make Toyota. And again, why do this HTML display for model.make? I'm trying to make a point here. Eventually I will. Versus, what's easier? At model.make. They both work. Okay? Why then make it hard? Why do this? HTML display for model arrow model.make. We'll get to a point where the attributes on our car, I don't know, maybe you have an attribute called engine size. That's 2 words, engine size, but in C#, there's no spaces. You can't have a property called engine size with a space in it. So you might change the way it looks with there's a display attribute. There's a display attribute, and it might be something like engine size. Okay, again, I gotta get my syntax right. But the reason is that engine size being 2 words, you don't want it to look like 1 word on the view. So the reason why you will see this HTML display 4 is because it respects those attributes on the model. Okay, it's not really necessary for this demo. For the sake of this, we could just say at model.make. Okay, once I've got this, this becomes model and year. Toyota Camry 2020. You see how I had to manually type that in though? Cars controller, details, and then I had to pass the 1 in. If I pass the 2 in, it'll change it to a Honda Civic. If I pass the 3 in, change it to the Ford Mustang. Okay, why did my details link not work? Well, my details link didn't work because if I go back to my index, my link is still href to nowhere. Like here's my details link. And I'm going to ASP action. This is details action. And then you have to pass in that variable. This is ASP route. This is a helper tag that allows a dynamic value, ASP route thingy. That would be the name of my variable called thingy. If you had a variable called pizza, whatever your identifier here, our identifier is called ID. We gave it the identifier right here. So this ASP route, let me save my car, close my car. ASP route ID equals, and I gotta pass in the ID here at item.carID. So now every time I'm looping through this list of cars, I'm putting the car ID in the details link. Okay, so now if I save that and I stop it and I go ahead and start without debugging, see if that spins up. Okay, details brings me there. I'm going to click back. Details brings me there. Click back. Details brings me there. And click back. Okay. So now the delete page, of course, delete is still wired up to nothing. We need a method. And that method is going to be a get method and a post, right? So we need to get, and we need to post. So 2 methods really for delete that belong in the cars controller. And let's go there. Cars controller. This method is going to look a lot like the details.
This one called HTTP delete.
I'm sorry?
There's a, I don't know what's it called, but there's one called an HTTP delete. So
Yeah. So HTTP delete, it just sounds like you're talking about the HTTP verb.
yeah.
Yeah, and we're going to be doing a get and a post. Okay, so here's our delete method that's going to belong on our cars controller. It takes in an ID, so we're going to have to formulate our link with the ID. Just like the other one, this is going to be essentially the first, it's just like an edit, right? If the ID is null, return not found. Otherwise, read the car out of the database. And then, if the car is null, return not found.
We already did that.
Yep. We did this. It looks just like our edit, really. Or our details, I should say. This looks just like our details. We're sending the car to the view that we're going to delete, right? We're doing a get operation. We're going to say, hey, are you sure you want to delete this car? Okay, but over here, under cars, we now need a delete CSHTML view. So here's our delete CSHTML. And our model is our car. And we could set the title. It says delete car. Now, this is really the same kind of jazz. Make, model, and year. I'm just going to copy and paste this in for the sake of your sanity and mine. This is a delete operation. Different question now. We're saying, are you sure you want to delete this? And then we're displaying this car. Anyone remember the DL tag in HTML? DL, definition list. DT, definition term. DD, definition data. And then here again, remembering this HTML display name for, display for. So this display for is the actual value. Display name for will read from the display attribute inside of the model. So that's the difference. This will say the make, and this will actually get the value out of it. Okay, but that's make, model, and year. Close that, close that. Looks like we've got one more closing div. Now there's no, let's see. Okay. So now I go back to my index. I got to formulate this delete tag just like the other one. ASP action is delete. ASP route ID at item.car ID. Now, there's a little bit of a trick here. In this edit, we got to get working. But let's just see that that link gets us to the delete page and see that it displays the information that we should delete. Okay, so I'm going to delete this guy. Okay, are you sure you want to delete this? Obviously, what we're missing is a big red delete button. I'm also going to say, notice that the car ID is not on this page, and that's actually a problem, because if you're going to send this information to a post method, you need that car ID. This get needs to send the car ID to the post method. And so for that reason, let me show you what my delete form looks like. So I'm going back to my delete page. Okay, this DL close that div. Before that closing div, here's my actual form that's going to call a delete post. So here I'm going to post to a delete. I don't have that method yet. And notice I have to store the car ID in a hidden field. You don't do that, this will break. If you don't do that, this will break. You heard it here first. I know it's a long lecture, but store the car ID in a hidden field. Here's our submit button type of submit, which we'll call that post. It's a delete button. It's got some styles to it. We also have a back to list. Okay, so now we need to actually go to our cars controller and wire up. This is a get method, HTTP get. And now HTTP post public async task iAction result. I'm going to call it delete. Now, again, I believe we take in a whole car C. And just let me double check my memory. No, we just take in the ID. Again, that ID was stored on the form in the hidden field. Okay, so here we find the car. If it's null, if the car is not null, we use a context cars remove, and then we save those changes. So we'll call a remove method, remove that car out of the database, save the changes, and now instead of just returning to the view, we're going to go back to the index action. So you could code this like that. Redirect to action called index. All right, I'm going to put in a breakpoint right here, and I'm going to start debugging because my gut's telling me this ID is not going to come in the way I want it to. We got one called ID, we got one called car ID. I just want to make sure. Okay, so this is ID of 1. I'm going to click the delete button. I hit my breakpoint. It did get an ID of 1. Okay, good. So my ID of 1 comes in. Car is not null. We remove cars. I'm going to hit continue. Notice my car is now gone. And again, the ID would have just been read from the route. Because of the routing right here. So delete is working. The next operation, we got 2 more operations, right? We got details, we've got delete. Now we've got insert. And remember I said insert and edit have the same form, so we're going to use the same form. Let me go back to my cars controller. There's also something you see a lot out there that's validate anti-forgery token. This is going to help you like a little bit of security. You can kind of read about it. This attribute helps defend against cross-site request forgery. It won't prevent other forgery or tampering attacks. This is a simple attribute to add that I see quite a bit out there. Let me kind of condense this down. Okay, so here's our cars controller. We've got our context, we've got our constructor, we've got our listing all the cars, a single car detail, a delete get, and a delete post. And the next thing we're going to do is add, but because of what I've said a few times now, add and edit use the same form. Bless you. Public async task I action result called add edit called car C. So when you call this method, if a car exists, it will have an ID. If it doesn't exist, it won't have an ID. So what you do is you see, hey, does my car have an ID? If my car's ID is 0, doesn't have an ID, we're doing an add operation. Otherwise, if my car does have an ID, then we're doing an edit operation. So I will start off, actually, int ID equals 0. I thought I accepted a car, but I accepted an int here. So right off the bat, if ID is 0, we're doing an add operation, and we go back to the view. A new car, we're just going to assume the year 2000. Instead of integers are 0 by default, so having a year of 0 doesn't make a whole lot of sense. But if we're going to start a new car, maybe 2026, right? It's just, what are the defaults for your cars if you're going to do an add operation? There's going to have to be an else block. Oops. We'll do that for now, and I'm going to come back and fix that. So keep in mind, this is the new car operation. This is an edit car operation. Let's add a view called add edit. CSHTML. At model is a car. Kind of a similar if-else. If the car ID is 0, we're going to say add car in the title. Otherwise, we're going to say edit car. And then we're going to put the title, again, it's either going to say add car or edit car inside of an H1. Okay, so I'm just trying to get the add car working, but I'm also kind of wiring this up for the edit operation a little bit at the same time. Remember that our layout had the anchor tag for add new car. So here I'm going to say ASP action equals add edit. So this is going to call the add edit action. And let's see if our link works. You guys feel run down yet? 2 hours ago? Okay, so here's add new car. I always, when I hover it, you see in the lower left it says cars add edit. You see my little URL that looks good to me. If I click on that, notice it does say add car and it does say add car. Okay, so I know it's my car ID is 0 and it's using the add edit view. Okay, so back to add edit. All right, form tag ASP action add edit. So this will be the post. You don't have to specify the method of post, but it helps. Readability, little y-axis space. Notice the first thing my code editor suggests is saving that car ID, which is input type of hidden, ASP4 car ID, so there is no car ID in a new car, but if I look at the first kind of form controls, we've got a label for the make and an input for the make and a validation for the make, and the validation of course is red text. So again, these tag helpers, ASP4, ASP4, ASP validation 4, along with all the Tailwind classes. Okay, a pretty simple label and a text box, but they're wired up to the make field of our model. Same copy and paste for the model. ASP4 model, ASP4 model, validation for the model. Same deal for the year. And last but not least, our submit button. Button type of submit, so we got a div, button type of submit with all the Tailwind classes. Bunch of Tailwind classes. Ternary operator, right? Is the car ID 0? The button says add new car, and this will say or update car. Of course, this submit button does.
Why would we need to update the new car?
Because keep in mind, this one form is doing both add and the edit operations. So you have to basically do these ternaries all over the place to see, are you doing an add operation or an update operation?
Why do we have the edit button?
Why do we?
Yeah.
We haven't got there yet, but we're about to. Okay. All right. So that kind of brings us back to this point. We got a button to submit and add a new car, but of course, we got in our car's controller, we have to have a post for that. So here, HTTP post, and same anti-forgery token, public add edit, and I'm not going to do exactly that, public async task I action result. I just take in the car. No, what do I do? Yeah, I do. I take in the whole car. If the model state is valid, let's just tab this in. If the model state is valid, and if the car ID is 0, then we add a new car. If the model state is valid and the car ID is not 0, then we update the car. Then we save the changes and take us back to the index action. And if the model state is not valid, we just return to the view the invalid state of the car, right, to display the error messages. So I kind of did both operations. I don't know if there's anything else I forgot to do for the edit. I was just going to show you add, but you got to kind of wire them together that way. Add new car, Jeep, Cherokee, 1994. That was my first car. Add new car. Okay. Good, but not good. Oh, there it is. What am I talking about? Not good. There it is. Jeep, Cherokee, 1994. Let's click edit. That edit button isn't working. If I click details, it is working. If I click delete, delete works. Add new car, Jeep, Cherokee, 1994, add new car. It would make me feel better if I close this down. I always just like seeing the data in the database.
But nothing's updating.
You gotta close the table and reopen it sometimes. And there it is, Jeep Cherokee 1994.
You added 2 Jeep Cherokees.
I deleted one. I added, deleted, and I added it again. So that's cool, and you can kind of see the car IDs are doing their thing. They're incrementing by 1. You got 2 and 3 seed data. The one that I added and deleted had the ID of 4, right? That's why it's missing 4. So it's auto incrementing on the primary key column. Primary key column is car ID. Okay, how to use Package Manager Console to create migration files. There were 2 commands. There was add migration, add -migration, and then the name of the migration. Then there was update database. Those were the 2 Package Manager Console commands. How to use link to query data. We've seen that a bunch in our controller. Specifically right here. This is a link query where you're looking for a car ID by the ID that's passed in. It's also this first, our default async. This is actually part of link as well. Describe how to use the methods to add, update, or delete entities in the database. Well, this is actually kind of pretty easy. To add, here you call the add method. To update, you call the update method. To delete, you call the remove method. So those methods are these methods right here. So add, update, or remove. Okay, I have not talked about 9 yet. I got to get my edit operation to work, and I got to show a couple more things there. All right, let's go ahead and fix the edit link. It's back under the layout. No, under the index. Here's the edit. And we we need the route ID. ASP route ID okay, so now hovering the edit, cars add edit /2, cars details 2, cars delete 2, cars add edit 2, there we go, add new car. This is the only one I think I did data validation, but it works just the same with as before. Oh, my cars collection could probably navigate me somewhere else besides pound. So let's go back to fix that little link. Layout. All right. So this is ASP action is just the index. Okay, so now, regardless, it's also the case on add new car. That's interesting. I can show you how to fix that. The active link is not really active. Notice the active link has kind of got that the background look to it. That's a problem for another day, but I just point that out that this nav bar is in the layout file. So how does it know, how does it know what action that you're on or what view that you're on? That's again a problem for another day. But if I go to edit, now Honda is working. Problem here is if I leave that blank. Oh no, I did fix that. Honda, that's good. Okay. So we got CRUD operations going. It's all with Entity Framework. A couple more things that I want to show off. Taking a look at these URLs. As far as URLs are concerned, a couple of best practices which we can make this URL better would be making them lowercased. So just a little bit cleaner when they're all lowercased, and it's also the case sometimes adding a trailing slash is something that you see as a recommendation for URLs. And so changing that to have trailing slashes and lowercased, thankfully that can be done pretty easily. If I go back here, builder services, add routing, options arrow, options lowercase URLs is true, append trailing slash is true. There's a couple of small things there for our URLs. And then while we're at it, Okay, so now we've got lowercase URLs and that. It also, I mean, obviously the car information is up here, but you would make a URL more readable. Like the number 2 doesn't really say anything, right? But if I were to say,
Well, no, that's the.
right, to an end user, it says something to us. We understand that's the primary key. We understand what 2 means, but to an end user, they probably don't. But Honda Civic 2019, an end user would understand something about that. If we actually put some information in the URL about the product itself. Okay, they call that's called a slug. I don't know where that name comes from. I don't know if that comes from let's Google that one. Where does the term slug come from as part of URLs? I thought it came from newspaper, from the newspaper publishing industry. It refers to the informal short name or label given to a news story during the production process to help editors and printers identify it. So it comes from newspaper. As another artifact from newspaper. Web developers get a lot from newspaper, believe it or not. So we're going to make a slug in the URL. Again, just making that URL a little bit more user-friendly. The way to make a slug is on page 173 if you guys have your book. There's 1, 2, 3 part process to making a slug.
What page?
173. Part 1 is you got to put the slug in the routing table, right? So here in the router, we got, hey, the first part of the URL is the controller. The second part is the method. The third part is a variable. It's called ID. The fourth part is this optional slug, right? Nullable ID, nullable slug. So if there's the path that follows that length, that, what do you call it, segment. First segment, second segment, third, and fourth. The fourth segment belongs to the slug. I'm going to go, we have to define what the slug is. So I'm going to go back into here, into my model. I'm going to define the slug. Now I'm going to say this is not mapped. Not mapped means don't put this in the database. Okay, now you can kind of see here, this is just a read-only string. It's not, there's no set block. But this is going to be the year followed by the make, 2 lowercase, and the model, 2 lowercase. So this is a string. I think that's called interpolation, string interpolation, where you're taking the year followed by a hyphen, followed by the make, 2 lowercase, followed by the model, 2 lowercase. So number 1, update the routing table. Number 2, update the model itself, the domain model, to have a slug. And the reason you do that is that so that back on the view, when we're going to delete or edit, those are the 2 times that you can, I guess you could put it in the details as well. Let's put an ASP route slug. So again, this is our ID variable, and this is a variable called slug. Right? We're just making these route variables. So a route variable called ID, a route variable called slug equals at item.slug. This property is available because we just made that property on the model, right? That wasn't available before. Okay, so those are the 3-part process. I'm just going to put this, I'm going to put it on all 3, I think. I think it can work for, I know it can work for edit and delete and maybe details. I think it should work for details. So let's run that up. It would make sense that it works for details. Okay, so if I hit edit, notice it is now saying in the link 1994 Jeep Cherokee. Click back. If I click delete, now it says 1994 Jeep Cherokee. If I click details, 1994 Jeep Cherokee. So again, just little things that you can do to make URLs a little bit more friendly. Okay. Last but not least, this textbook, they go over not just one table, but having multiple tables in your database. Okay. So when you have tables in a normalized database, there can, broadly speaking, let me see, okay, you have three kinds of relationships between tables. You have these different tables, and tables link together, right? So tables link together through their keys, okay? And so you might have a primary key called student ID, right? So a student has a student ID, right? A class has a class ID. These are primary keys. Okay, but in the class table, you know, if a student ID is student 1, and that's Anna, you have a student ID of 1, right? And you have a class of AWD 1115, that's this class. You know, so the class ID is 1115. If I put student ID of 1 in class 1115, that means Anna's enrolled in this class, right? So when I put the student ID inside of class, what's that called? What's that column called? If you have a student ID column in the class table, what's that called? It's not the primary key. What's the other key that we've heard of? Huh?
Secondary key?
No, good guess. It's called the foreign key. Okay? So if that makes sense, the class ID is the primary key. But if Anna has a student ID of 1, when you put the student ID of 1 in AWD 1115, that's how you enroll that student in that class. Okay? So broadly speaking, you have primary keys, which enforce uniqueness in a database table. So okay, primary keys enforce uniqueness in a database table. Every row has to be unique according to the primary key constraint, according to the primary key rule. Foreign key link tables together. It's how you say, okay, this class has a student ID of 1, and this class has a student ID of 2, and this class has a student ID of 3, and student ID of 4. Those are the 4 students enrolled in this class. Okay, so foreign keys kind of link the tables together. Tables are linked together through their keys, through their primary keys. Now, there is no student ID number 10 in this class. We only have 6 students in this class. There is no student ID of 10. So you cannot have a student ID of 10 inside of a class, because if that student ID doesn't first exist in the student table, that is a violation of the rules, right? Student ID of 10 has to be a valid student ID. You cannot put a student ID inside of a foreign key value that does not first exist inside the primary key value. So I'm going to try and spell that out. You cannot have a foreign key value that does not exist first as a primary key. Okay? So if there is no student ID of 10, you can't put a student ID of 10 inside of a class. That is it will not work. The database will give you an error. Okay? All right. So that's a little bit about tables. Now, Depending on the entities themselves, tables can have three kinds of relationships. One to one, one to many, and many to many. Okay? So this is called, these relationships are called their cardinality, aka cardinality. Okay? So depending on the things, you know, a student on one side can have many courses, and a course can have many students. So between those two entities, student and course, you have a many-to-many relationship. Okay, and we're going to get into many-to-many. We're going to get into one-to-many. But we're going to start with the easiest one, which is one-to-one. Okay, a one-to-one relationship is where we're going to start today. Okay, so we're going to have multiple tables that have these two entities that on each side, so a car and car details. So our one-to-one relationship is going to be car and car details. One car can only have one car detail, and a car detail belongs to one car. So it's a one-to-one relationship. So a car detail, this is like the heavy, lots of information about the car. The car entity itself is going to be kept lightweight, just the basics of the car. Car details might be the engine size, the weight of the thing, you know, how many screws it has, all the heavy details. And I'm going to explain why you would separate them out. Because you might say, Mr. G, can't you just put the car details inside of the car? Why do we need two separate tables? And I would say you could. You could put all of the car details inside of car, and that would work. But there are some benefits to separating them out. Okay, there could be some benefits. So the one thing that was kind of an eye-opener for me is that one-to-one relationships are typically optional. They're not a hard requirement. You could put one card table with all the information in it, and that would work. It might have some downsides or some trade-offs, but they are, one-to-one relationships are optional, okay? But they are a valid kind of relationship, and they do have some benefits why you would consider them. So we're going to make a car details table that's going to have a one-to-one relationship between a car. A car has its own unique set of car details. So this is going to be done here by adding a class called car details. Now, very typically, you would have a ID for car details. This table would have its own primary key, and think of this as its own auto-incrementing number. I set this up because of a one-to-one relationship. I set the car ID as both a foreign key and a primary key column. One car can only have one car details. A car can't have two different sets of car details. So I set up this car ID as both the primary and the foreign key in this table. And when we get into, well, what are the car details? Well, we can get into the engine type, the horsepower, the color, whatever you may have. You need to actually link these two things together. Okay, the car needs to be linked to the car details. The relationship goes both ways. Okay, so on the car side, there's two things you need here. Maybe it's two things. I'm going to say public. I'm going to mark it as virtual of car details. This is referred to as a navigation property. Okay, so a car has car details. So this will allow us to say C1 dot car details dot engine size. It allows you to navigate down into your car's details. And it's also very common on these navigation properties. Again, I already know some of you will hit this. Validate never. Zone in for me on this one, guys. When you have, look at my screen, please. When you have a navigation property, okay, the way this works is that this might and will take your model state to invalid if you tell it, unless you tell it to validate never. So you will have validation errors unless you tell your navigation properties to validate never. So you very commonly want to do that. So this navigation property takes us from the car to the car details. I'm also going to go over here on the car details, and we're going to get it going back to the car. It's kind of a two-way street. So we're going to have a virtual car called car. So we're going to navigate to the car details, and then from the car details back to the car. Okay, save, save. Okay, and I kind of mentioned this earlier that I want my details page to display these additional bits of information. But my cars don't have that additional information. Now that I've wired these up, I need to, my database itself has changed. By adding this car details class, I now have a second table. These two tables have a one-to-one relationship. And I'm going to put some seed data back in here in my car context. This is kind of a cool thing to see here. This seeded my cars. I'm now going to seed that second table with information. So it's going to look very similar here. Model builder dot entity car details. Let's just fill this in. Now this is car ID 1. Car ID 2, car ID 3. Okay, so my Toyota Camry is red. Why is it not happy with miles? Oh, horsepower. Horsepower. Just making up the horsepower. I'm going to assume the Mustang has more horsepower, yeah? Horsepower of 300 horses. Okay, so follow me here. Car ID of 1 is a red Toyota Camry, 200 horsepower, and the last engine type is a 2.5 liter 4-cylinder. Engine type is 2.0 liter 4-cylinder. And engine type 5 liter V8 on the Mustang. Okay, I'm going to shut this down from running. Stop, stop. Okay, now I've changed my class. An important thing to realize, you change your class, you're changing the database design. You're changing the database structure itself. So we actually have to go back to our package manager console. We're going to add migration. We're going to add the car details table. So we're going to run that same add migration command, and this is going to modify our database schema with a new table if it builds and if it works. Build succeeded, that's good. It'll generate a new file. That's good, it worked. So we're going to create a new table called car details. Here's our tables in that column. It's got a primary key of the car ID. And we're going to insert some data for our cars. Okay, so that generates the migration file. To run that, we're going to run the update database command. So now we should have two tables with a one-to-one relationship. Oop, didn't like something. Okay, car ID 1, car ID 2, car ID 3. I already inserted some data, and I'm thinking because I did that, it is trying to insert the same car ID of 1 twice. I'm going to delete my database because no harm there. I'm going to try running the update database command there. It should, let's see if it hits any errors now. Okay, that worked. Okay, so the problem was it was trying to reseed the data that was already in there. Okay, just delete the data, recreates the database, and you're not at risk of losing anything. It's just dummy data anyways. So now is my car DB2. Here's my tables. Notice my cars table. I gotta close it and refresh. Let's try that again. Okay, there's my cars table, car 1, 2, 3. And my car details. Okay, car ID of 1, car ID 2, car ID of 3. And it's kind of cool too. You can go into car details and you can look at the columns. You can see there's a primary key and a foreign key, right? PK, FK. This one column is both my primary key and my foreign key. Primary and foreign key. Okay, this is a non-nullable, non-nullable, non-nullable column. So you can kind of see the database design a little bit in here. Okay, so it just got a little bit more complex because now we have multiple tables. I'm going to take us back to the controller. Okay, so if I kind of go back to my controller, here's my delete. Here's my delete. Okay, what I want to show up is I want those additional details to show up in my details view. And so here, notice I'm hitting my car, and I'm getting first our default async. And there's an includes. Now my car includes car details. So I actually have to change this query up a little bit. This was the old query, and this is kind of one of the more var car equals await underscore. Now it actually picked up what I was trying to do. I'm going to, in my cars table, I'm going to include the car details. Really, that's all I needed. It wasn't so different of a query. So now my car and its car details will be sent to that view. But now I got to display the car details in the view, right? So that's in this details view. Notice this was just displaying the make, model, and year. But now I've got those additional details. And so if I kind of add another div here, here's my div. and this is car details. And you might want to mark it as a, let's see, possible null reference. Model, you don't do that. Model, no, car details here. I'm coded out for the day. I'm forgetting what to do here. It's saying it could be null, like car details. Your car might not have car details. So I want to say car details is nullable. Now, here, car, I'm just going to take that off. I don't want you to be nullable. And so now you're not giving me that warning. I'm sure there's another way of fixing that, but here, this is the engine type. And let's see if our car details are now being displayed. Okay, so if I click on details here, my engine type is coming across. So I am pulling that out of the other table. So what I'm doing is I'm kind of joining these two different tables together. You guys will remember SQL joins, yes? You've got data in two different tables, you join them together. I can do the same kind of deal, not only for the engine type, but now it's car details, car details, car details, car details.color. And again, the syntax different between the top and the lower. Talked about that. Now you could see my red Toyota Camry, my blue Honda Civic, my black Ford Mustang. So almost done. I do want to offer a slightly better explanation on one-to-one relationships. I just took a couple notes that I want to share with you guys on these one-to-one relationships, which are optional in many cases, but they do have, like everything in life, they got trade-offs. So okay, so down here is where we created this navigation property, which is part of the one-to-one relationship. So when you're designing a database, you have two different entities, two different things, and you have a one-to-one relationship. When one table, table A, is associated with exactly one record in table B, and vice versa. So it's a two-way street, right? Table A is one to table B, and there's one entity to table A. So a car can have one car detail, and a car detail can belong to exactly one car. So there's your one-to-one relationship. So when is it beneficial? You could technically put all information into one massive table. Splitting it up into a one-to-one relationship is beneficial for these scenarios. Okay, table bloat and performance. If you have dozens of columns that are rarely accessed, so you've got this giant table, you got all this data that you're rarely accessing, a bunch of the table. Moving them to a separate table keeps the main table lean and fast to query. So again, you just, in database design, you come across these tables, they've got maybe 20 columns, 30 columns, 40 columns all in one table. But a lot of those columns, you just never access the table. So when you query, you select star on the whole table, you're reading a bunch of data out of the database that you might not need to read, so that you would just be able to query the main chunk of the table, the data that you need, right? So it would be a faster query, keeping that table lean, right? Not putting extra columns in it that you don't need. Okay, so that's one scenario. The next scenario is security and separation of concerns. If you didn't hear it last year, you've heard it here now at least twice. Separation of concerns when it comes to MVC. You might want to store public car info in one table and sensitive private data like GPS tracking history or maintenance logs in another with restricted access. So there might be some private records that you want to store into a different table that's not quite so accessible, right? So these are two reasons to consider, and I realize, in our small apps for college and for class, these are more real-world scenarios, I would say. But these are when scenarios make one-to-one relationships beneficial, because they are optional. You never have to have them necessarily. You could just store it all in one place. Okay. So that being said, chapter 4 is a doozy. All this is in the chapter. All this theory is in the chapter. I believe we covered it all. We modified our URLs to make them more user-friendly, and we put in some slugs. Describe how you can code a foreign key for an entity by convention. What I didn't do here this is by convention going to link you to the car ID just by putting the car ID here. I added this attribute. This would still work to be a foreign key column. This is a foreign key by itself, but by marking it key and foreign key. So this by itself is technically a foreign key, but when I do this and I mark it as a key and a foreign key, it kind of explicitly makes it a primary key as well. But I just wanted to answer, how do you make it a foreign key by convention? By convention means automatically, is just by, again, the prefix of car, ID, suffix. Okay, so that covers all the objectives. Whole lot of new information in this chapter, and I'm going to stop the lecture here.